Okay, so now we're looking at another compound interest investment, this time $8,000, 12.5% compound each year. Hasn't told us there's any other compounding period, so we're just going to leave it as is. And now we're doing VN as the value of the investment after n years. So previously we did, recursion relations, which look like this, V0 equals A, Vn plus 1 equals RVN. Now we're going to do something that goes straight to term n, so Vn equals r to the power of n times v0. That'll jump us forward n sets of compound interest or whatever that we're doing. So when we write down a rule for the value of the investment, we need to know r, which again is still 1 plus little r over n over 100. And we need to know v0. So the capital R rate, this time 1 plus 12.5 is going to go in here. 12.5 divided by, there's no extra compounding period, so it's just 1 over 100. And don't be afraid to go to the calculator on that. 1 plus fraction 12.5 divided by 1, didn't really need to do that, divided by 100, 1.125. We know V0, which is $8,000. So we can put our rule together, Vn equals 1.125 to the power of n times 8,000. That'll take us straight to term number n. So we want to find the rule to find the value of the investment after 3 years. So for n equals 3, we say V3 equals 1.125 to the power of 3 times 8,000. And that's something we're definitely going to do in our calculator. So 1.125 to the power of 3 times 8,000. $11,390.63 near cent. 11,390.63. How much interest was earned in the third year of the investment? In order to do that, we need to know V3 and V2. And we subtract the difference between V3 and V2 because the amount that the investment grew in that time will be the interest earned in that year. So we know V3 already, 11,390.63. Now we need to find out V2 using the same idea as what we did up here, except I'm just going to do it squared. So if I go back to the calculator, I could even borrow this previous line, change that 3 to a 2. Whoops, that's not right. Let's try that again. And there we go, squared. 10,125. And if I work out the difference between those two, 11,390 minus 10,125, just correcting the first one for cents. That's 63, $1,265.63. There we go. Our second example here is about a car being purchased at a certain price and then being depreciated using reducing balance depreciation method. So at first the car is purchased for $38,000 and depreciates in value at 9.5% per year, reducing balance method. So that means we're using this multiplication sort of thing. And we're doing Vn, the value after n years. So same deal, Vn is equal to r to the power of n times V0. In this case, because it's reducing, capital R is 1 minus little r over n over 100. Most reducing balance questions will have a reducing period of every year, so compounding periods of a year. Sometimes they don't, just be aware. So if we're going to try to find a rule, we're going to go 1 minus 9.5 over 1 over 100. Go to the calculator. 1 minus 9.5 over 100, 0.905. And we already know what V0 is, $38,500. So Vn is equal to 0.905 to the power of n times $38,500. This term 905, because it's less than 1, when you multiply this number, 38,500, by a number that's less than 1, you'll get a smaller number, which means you're depreciating. Use the rule to find the value of the car after 5 years. So n equals 5. V5 is equal to 0.905 to the power of 5 times 38,500. Go to the calculator there. 905 to the power of 5 times 38,500. We'll go near a cent again. 23,372.42. 23,372.42 is V5. The total depreciation over 5 years is the difference between how much it started with and how much it's currently worth. So V0 minus V5. That tells you how much value you've lost over those 5 years. So $38,500 minus $23,372.42. Again, go to the calculator. 38,500 minus 23,372.42. So it's lost $15,127.58. 15,127.58. Okay, that's the total depreciation. Finally, just looking at this last question here, how long would it take for $200 to exceed $20,000 if it was invested at 4.75% per annum compound interest? What we're going to do is we're going to make our Vn equals r to the power of n times V0, where 200 is going to be V0. R is going to be a form of 4.75, and we're going to find $20,000 and we're going to solve for n. So first we set up our expression. So Vn equals R, compound interest, 1 plus 4.75 compounding yearly, so just 1 over 100. 1 plus 4.75 over 100. 1.0475. So that's going to be R over here. 0.0475 to the power of n times 200. We want Vn to be equal to 20,000. So we're going to get 20,000 is equal to 1.0475 to the power of n times 200. And that's the sort of thing that we're going to do solve on our calculator. So menu, algebra, solve. 20,000 equals 1.0475 to the power of n times 200. Solving for n gives us 99.235, so 236. N equals 99.236. What that means is that sometime during the 99th year, it will get to $20,000. But because the interest is compounded annually, we haven't been given any other compounding period, we have to go to the next whole compounding period. So if we did 99 years, we have to do the same thing, 1.0475 to the power of 99 times 200. It falls just shy of 20,000. If we do the same thing again to the power of 100, should be just over $20,000. So that means we've got to wait 100 years in order for it to get to $20,000 at 4.75% compound interest.